Hello, everybody, and welcome to Mrs. Baker's Chemistry Corner monster paper for Module 10. That's the metals module. This is question 7. So, displacement reactions occur between metals and metal ions. Displacement reactions can be used to determine the order of reactivity of metals such as lead, nickel, and silver. The ionic equation for the displacement reaction is shown. So, this is saying that nickel as an atom plus lead as an ion makes lead as an atom and nickel as an ion. The ionic half equation for the reactions are shown here. So again, that's just backed up what we've said. Nickel is going to nickel as an ion, and it is giving out 2 electrons. And lead is going from an ion, it's gaining 2 electrons, and it is making lead as an atom. The ionic half equations show that electrons are donated by the nickel atoms and they are accepted by the lead ions. Identify the reducing agent in the displacement reaction. So a reducing agent is the one that has itself been oxidized. Well, in this case, we're going from in the nickel's case, we're going from 0 to plus 2. A 0 to plus 2 is an increase. An increase is oxidation, which is in fact loss, and it makes us the reducing agent. Conversely, the lead is going from 2 plus to nothing, so that's a decrease. That a decrease is always reduction. Remember, decrease and reduce, they're the same, they mean the same thing. A reduction is gain, thanks to oil rig. Oxidation is loss, reduction is gain. And if we have being reduced, then we are the oxidizing agent. So in this case, we need to identify the reducing agent. The reducing agent is here. It is the nickel. So Ni, remember we put Ni, we don't put Ni2 because only things on the left-hand side of the equation can be oxidized or reduced. The reason is because you can have 2 things that they will award. It's either that it has lost electrons, or you could also have that it has increased in oxidation state. Both of those points would have got you the 1 mark that you needed. What is the general term given to the type of reaction in which electrons are transferred from one species to another? It is, of course, redox, or reduction and oxidation happening at the same time. Okay, so the ionic equation for another displacement reaction is shown. We've got lead as an atom going to lead as an ion, and over here we've got silver as an ion going to silver as an atom. So let's write the 2 half equations. We've got lead as a solid, but in this case we don't need to put our state symbols. The only time in the exam that they will award you marks for state symbols is when they expressly tell you that you need to include state symbols. So even if you don't write your state symbols here, then you are not going to lose any marks. You've got 2 marks available, and it'd be 1 for the correct ionic equation minus the state symbols. If they wanted to include state symbols, they would have said, and it would have been a 4-mark question. So lead going to lead as a 2 plus ion. Notice how I've left a lot of space, because on one side I'm going to need to put my electrons in a moment. So here I've got 2Ag as an ion going to 2Ag as an atom. So in this case we know that Pb going to 2 plus is, so the Pb goes to 2 plus, so that is an increase. If it's an increase, it must be oxidation, and oxidation is loss. In the silver's case, it's silver going from a 1 plus to a nothing. That is a decrease in oxidation state, which is reduction, which is gain. So in this case, if I'm gaining, I must be taking in. so plus 2E minus, and if I'm losing, I must be given out, so 2E minus plus. And that way we've got them on the right sides of the equation, our electrons. Use the information in A and B to put three metals, lead, nickel, and silver, in order of reactivity. So in this case, if we want to know which is the most reactive out of two metals, it's the one that's the ion at the end. So in this case, we know that lead beats silver because it's an ion at the end. So we know that lead beats silver. If we go up further, we know here we've got nickel versus lead, and in nickel versus lead, nickel is the ion at the end, so nickel must beat lead, so therefore nickel goes here. So in this case, it's nickel, lead, and silver. Nickel is a transition element. Nickel is stronger than sodium. Describe two other differences in physical properties of nickel and sodium. So this is the classic compare the group ones with the transition metals. And in this case, the physical properties that we want to talk about, there's always two physical properties that they like you to roll out. Number one is that sodium in this case, remember it's a quantifiable question, so you can't write it because which one do we mean? In this case, sodium is less dense. All group 1 metals are less dense than the transition metals, and also sodium has a lower melting and boiling point. All group 1s have lower melting and boiling points than the transition metals. Remember not to write MP and BP. Don't be lazy because your examiner doesn't know what you mean by MP or BP. Predict one difference in the appearance of aqueous solutions of nickel compounds compared to the aqueous solution of sodium compounds. And what this is asking is that they want you to know that transition metals form coloured compounds. So in this case, 1 mark, you would say nickel compounds form coloured solutions. Sodium compounds form colourless solutions. Copper is refined or purified by electrolysis. Nickel can be refined using a similar method. The diagram shows the refining of nickel by electrolysis. Complete the labels in the boxes. Well, because we've learned about copper, we can apply what we know to nickel. So we know that the anode and the cathode, in this case, the electrolyte must be made up from a nickel substance. So we're just going to pick a nickel salt, let's say nickel sulfate, because we know that we use copper sulfate in purifying copper. Now the cathode we know attracts the cations, so it's the cathode that in which so it's the cathode in which the metal is going to build up on, because all metal ions are cations. So we want this to be made of pure nickel. If we don't make it out of pure nickel, then we're just going to add more impurities to our cathode, and we're not going to get the pure nickel that we want. So it must be made of pure nickel as a starting point. The anode must be made of the impure nickel, because that's the bit that we want to purify. Okay, so hopefully that makes sense to you. Indicate by writing N on the diagram where nickel is produced. So we know that nickel is going to be produced here at the cathode, so we can just put a big N across here at the cathode.